In today's activity, Lesson 9.1, Property of Radicals, we're going to take a look at Part 2, where we're going to perform some operations with radicals. We're going to go ahead and start here at Example 2. So let's talk about a real-life application of radicals. The distance d in miles that you can see on the horizon with your eye level, h feet above the water, is given by d equals the square root of 3h over 2. How far can you see when your eye level is 15 feet above the water? So let's take a look. So we have 15 feet, which is our height, so we're going to place that with h. So we have d over the square root of 3 times 15 over 2, which gives us the square root of 45 over 2. Now remember, we need to rationalize our denominator here. So we're going to multiply both by the square root of 2. So we now have the square root of 90 over 2. And 90 is 9 times 10. So that gives us 3 times the square root of 10 over 2, which, when I do the calculations, is approximately 4.74 miles. Now, honestly, we could have found this here. However, I wanted to show you an extra step and how to rationalize that denominator as part of extra practice. All right, so now it is your turn. So go ahead and do example 6. Pause, and when you're done, come back and let's check your work. All right, so you ended up with number 13, approximately 7 25 hundredths miles. Now next, let's take a look at the learning target. Students will perform operations with radicals. So we're taking a look here at example 8, adding and subtracting radicals. Now, if this was 3x plus 2y minus 2x, we would combine the x's. Radicals work in the same way. In order for us to add or subtract radicals, the radicands must be the same. So we need like terms. So here and here are what we have as like radicals. Think of them as like terms. Both have a radicand of 15. So now I can go ahead and subtract them. Think about these as the variables and these as the coefficients. Now this is the coefficients of the radicals. So when I do that, 2 times the square root of 15 minus 3 times the square root of 15 minus 2 times the square root of 15 is, well, 1 square root of 15. And then I have my like term left over, or my term left over, 2 square root of 13. Now, if we look at the next one, we have no like radicals. So does that mean we're done? No, that means something's probably going on here that's going to allow me to eventually add or subtract these. Now, if I look here at 63, there is a perfect square factor of 9. So this is the same as the square root of 9 times 7. Now, a big hint here is this radical, or this radicand is 7. So if I divide 63 by 7 to have a common factor of 7, that's going to help me out. And it just so happens I have a perfect square. So this is 3 square root of 7. So now I have 5 square root of 7 plus 3 square root of 7, which then gives me 8 square root of 7. Now it's your turn. Go ahead, hit pause. Try these next few problems. When you're done, come back and check your work. All right, with 15, got to be careful here because we have a coefficient. So the square root of 9 is 3. 6 times 3 is 18. So we end up with 18 square root of 7. Then we have 4 square root of 7 minus 18 square root of 7 gives us a negative 14 square root of 7. So now let's take a look at multiplying radicals. There are two different ways to do this. And so it's really up to you which one works best for you? Now, the first one is just straight up distribution. And we've used the distributive property before. So here, we're going to distribute. So 7 times the square root of 3, or square root of 7 times the square root of 3. So I have the square root of 21 plus square root of 7 times the square root of 48 gives me the square root of 336. Now, looking at 21 does not have a perfect square factor. And 336, lots of possibilities there. But what I'm going to do is use this as a guide because I would like a radicand here of 21. So 336 divided by 21 is going to give me 16. So I have the square root of 21 plus the square root of 16 times 21. So I have the square root of 21 plus 4 times the square root of 21 to give me a final answer of 5 times the square root of 21. Remember, coefficient here is 1. Now, the other way to do this is to simplify first. So what I'm going to do is take a look at this 48. So I have the square root of 7 times the quantity, square root of 3, plus now I know 48 is 16 times 3. So at this point, I'm just rewriting it. Okay, so now I have common radicands here. So I have 7 times the 5 square root of 3. So now multiply my radicands here. 5 times the square root of 21. And if you notice, in both cases, I ended up with the same answer. So whatever one is easiest for you, I want you to go ahead and try number 16. Hit pause, and when you're done, come check your work. Whether you use method 1, distributing, and then simplifying, or method 2, simplifying first, you will still end up with 36 times the square root of 6. Nice job. Go ahead and get started on today's assignment.